Hi, and welcome to this flipped instructional session. This lesson is from Semester A of Earth Science, and today our topic is Fossils and Index Fossils, which is part of Unit 3, Lessons 8 and 10, and I am Mrs. Fessel. So first we're going to talk about why are fossils so important. So studying fossils can give us clues about what our planet was like millions of years ago, because we weren't around then, but these fossils were, so they can give us ideas of what it was like. It can tell us what organisms existed and even how they lived. Fossils also give a record of the changes our Earth has experienced over time. So as you can see, fossils are very important. So how is a fossil formed? So first, an animal is buried by sediment, such as volcanic ash or silt, shortly after it dies. Its bones are protected from rotting by the layer of sediment. So for example, you can see this dinosaur here might die, and then this volcanic ash is going to cover it. As time goes on, more and more sediment layers accumulate above the animal's remains. And minerals, such as silica, which is a compound of silicon and oxygen, slowly replace the calcium phosphate in the bones that are there. But now the fossil's deep underground. So what has to happen next is movement. Movement of tectonic plates, which are the giant rock slabs that make up the Earth's surface, lift up the sediment and push the fossil closer to the surface. Finally, erosion from rain, rivers, and wind can wear away the rock layers on top. Eventually, all of this erosion, or people digging for fossils or even just digging for construction, will expose the preserved remains. So from that, our definition of a fossil is fossils are traces of pre-existing life, which may exist in the form of shells, bones, or impressions of the plant leaves and soft body parts. It probably does not take more than hearing about a few fossil discoveries to get your mind thinking about what life may have been like long ago. Here are some things to think about. Remains of early reptiles were found in tree trunks in Canada. Fossilized dinosaur eggs were found in Mongolia and Argentina. Fish that appear to be developing limbs were found 600 miles from the North Pole. Shark vertebrae were found in Kansas. So as you can see, fossils, especially where they're found, can be both interesting and puzzling. In this picture, you can see a Park Service staff member at Dinosaur National Monument in Utah and Colorado chipping away rock to reveal these dinosaur bones. So there are two types of fossils, body fossils and trace fossils. So body fossils record the shape and structure of an organism. For example, the bone of a dinosaur and the imprint of a leaf are two body fossils because it tells us about the shape and structure. Trace fossils, on the other hand, record the movement or behavior of an organism. The footprints of a dinosaur and the burrow of an ancient shrimp are both trace fossils because it's not the animal itself, but it's something that the animal left behind, a burrow or a footprint. So right here, this would be a body fossil because it's the left behind bones of a dinosaur. So when you have a body fossil, there's soft parts or hard parts. So for example, a clamshell has a good chance of being preserved because it is the hard part of an organism. The soft part of the clam inside will decay. So if the empty space in the shell is filled with sediment, a mold of the shell may form. Even though the shell might disintegrate, that mold will remain and they can still see the shape of a clam. It's like filling a mold with Play-Doh or filling a cupcake mold and letting it bake. You'll still see the shape of it. So in this case, over a long period, rock has replaced the hard parts of that starfish. Many plants and animals, including trees and worms, do not usually become fossils. Why? Because they weather away too quickly. But in special cases, the soft parts can be preserved. For example, fluids can flow through tree trunks and replace the soft parts with hard mineral crystals. This results in petrified wood. Another example is over here. A leaf can fall into mud and leave an impression. When the leaf decays, the impression will remain and may become a fossil when the mud hardens into rock. So here's an example of how a trace fossil can occur. If a footprint is left in the mud can dry. Wind and water put layers of sediments over the footprint. Over time, pressure and the weight of the overlying sediment turn the underlying sediment into hard rock. And just like we talked about before, the top layers can erode away, revealing a fossilized footprint. So there are many stories told by fossils, which we already started talking about a little bit. Fossils can tell us how life has changed since ancient times and what has stayed the same. It can tell us the type of environment where rock layers were originally deposited. Rock layers with fossils of sea life that can be found on mountaintops must have moved very far from where they originated. Changes in the environment, for example, marine animals and plant fossils found above sea level, must mean that a change in sea level occurred. So this brings us into index fossils, such as this placoderm that lived 400 million years ago. And we're going to talk now about why index fossils are so important. So in order for a fossil to be an index fossil, that fossil needs to be easily recognized, existed over a wide area, such as throughout an entire ocean, but it only existed for a limited period of time. So that may cause you to ask, why is it a good idea? Why is a good index fossil one that existed for a short period of time? And that's because then scientists can date the rocks that fossil is found in. If they know a certain fossil lived only 600 million years ago, if there's a fossil of that plant in a rock, scientists know that rock must be about 600 million years old. Some other reasons why index fossils are important. Index fossils can also give clues about the environment in which they and other fossils formed. For example, suppose the index fossil was small, hard-shelled, and resembled organisms that today live only in the ocean. Scientists then say that rock layer must have once been covered by an ocean. So that fossil provides clues to paleoenvironment. And a paleoenvironment is just an environment of long, long ago. Like paleontologists study the Earth long ago, a paleoenvironment is an environment that existed long ago. So here's some examples of index fossils that geologists use. So each of these fossils existed only during a certain period of time. So scientists know if they find, for example, this shell fossil, that any other fossils found in that layer must be from the Triassic period and must be a certain age. So these are real examples of index fossils that geologists use. So index fossils can be used to match up or correlate rock layers or strata. Geologists can figure out the timeline of fossils by studying fossils and strata all over the world. They keep two important things in mind. Sedimentary rock layers are deposited one on top of another in horizontal layers. The oldest layer is the bottom, and the youngest layer is at the top. Often species appear at a certain time and become extinct at a later time. Once a species becomes extinct, it never appears again. As we are talking about, an index fossil is one that occurs only during a specific geologic time and can be used to identify the rock layer that it is found in. So that's what the teacher-graded assignment for this unit is, which is lesson 3.11, is about index fossils. When you complete that assignment, you're going to be placing index fossils in the correct rock layer and then correlating it or comparing it to another layer of rock to see if you can match up which layers were formed at about the same time. So as I was saying, that brings us right into the 3.11 graded assignment. The flipped follow-up this week will be the 3.11 graded assignment. So I hope you can join me to complete this assignment with your classmates. Thank you for watching and have a great day.